will introduce our next speaker to provide an industry perspective and to share how materials engineering is applied to develop innovative products and technologies that have a real-world impact. It is my pleasure to introduce Mr. Kalana Bamanuarachi. Mr. Kalana is an alumnus of the Department of Material Science and Engineering, University of Moratuwa, graduating in 2015. He currently serves as the head of Discovery Labs at Mars Innovation Private Limited. With extensive experience in product innovation and advanced materials, he leads the development of next-generation solutions at Mars Innovation. His work spans materials engineering, product development, manufacturing, and commercialization, and he has contributed to the development of innovative wearable technologies and smart textile solutions. We are pleased to have him with us this evening to share his professional journey and provide valuable insights into the opportunities available for materials engineering graduates in the industry. Ladies and gentlemen, please join me in warmly welcoming Mr. Kalana Bamanuarachi. Mr. Kalana, the floor is all yours.
Hi everyone. Thanks for having me. My name is Kalana and I'm with MAS, and MAS, it's a R&D function. MAS's R&D function is called Twinery, and I'm leading one of its tech arms called Discovery Labs. So Discovery Labs is a central tech development bench for MAS innovation. So I'm currently giving the leadership to two different teams, material science and chemistry team, as well as general engineering team. So as you are aware of, I'm a product of material science and engineering. I got graduated back in 2015. So today I thought of giving you some sort of a glimpse of how the industrial landscape would look like in material science and engineering. More focus into local landscape and bit of a touch up on how the global landscape would look like. You can stop me at any point and ask any question, or we can stay till the session concludes and then go for the questions. So I would like to start my session with why material science and engineering. So this is pretty profound that it is the invisible backbone of the industry. We used to call it as no engineering without materials. So every product that you touch, from your mobile phone to the chair that you are sitting and the devices that you are using, as well as road under your feet, moving from a huge spectrum, all are there because of the wonders in material science and engineering. And material science and engineering would bridge the fundamental sciences like physics, chemistry, and create relationships between fundamental sciences and some of the core areas like manufacturing and engineering, which makes it a more versatile, more agile field across the other, compared to other engineering disciplines that you can think of. The beauty of this very discipline is you will get the ability to understand how matter behaves. Once you got that ability, you know how to engineer it and engineer it for a purpose. And this very knowledge, this quantum of knowledge would be applicable across any field that you can think of. That's the value of and the beauty of this very discipline. So what makes MSc graduates are pretty unique. Like I said, it's a cross-disciplinary expertise. You can bridge between chemistry, physics, mechanical engineering, you name it. Everything would be coming under material science and engineering bucket. And you can go down into the very atomic level and understand how matter would work and engineer accordingly. And there's a huge global demand. Now I'm confident that you are pretty much aware of how this global demand would have derived and the sort of opportunities that are lying ahead of you. And the final part is this discipline is future-proof. as you really look at it, the technological curves of world has ever seen is always unlocked through the wonders of materials. Moving from vacuum tubes, I'm pretty confident that you must have heard of all of these stories. So the technological growth curve is defined by the wonders and the advancements in material science and engineering. So nowadays, the new conductive materials and stuff like that are circling around. You must have heard of graphene, fluorine, smart polymers, actuators, and stuff like that. All are products of material science and engineering. So this discipline, I can confidently say, is a pretty future-proof a discipline. So wherever the time horizon that you can think of, there will always be a component coming from material science and engineering. So having said that, I thought of walk you through around some of the local opportunities that the Sri Lanka is currently providing. The Sri Lankan manufacturing landscape is more diverse than many of us realize. The country is in its growth trajectory. There is a profound and substantial manufacturing landscape exists in Sri Lanka. So I would like to start off with my own industry. So this is one of the most prominent industries where a material science and engineering expert can contribute, the textile apparel. So in Sri Lanka, the 40% of the national export is done through textile exports. And out of that, these are some of the biggest players, MS, Brandix, Hydromani, and some of the other players as well. So this is one of the most prominent areas where material scientists can contribute, as well as solve some prominent problems and create some wonders. So this industry is responsible of catering some of the prominent brands in the world, just to give some sort of names like Victoria's Secrets, Lulu, Adidas, Nike, you name it. Almost all the industries which exist in the world out of Sri Lanka, we are catering to those. And the solid tires and rubber, it's again a prominent industry in Sri Lanka. I thought of bringing in some of the profound employers to the table so you can understand the quantum and you can see the numbers. So I don't want to go through each and every the icon here, but just look at some of the names that you can see here. These are the areas where in solid tires and rubber industry, some of the prominent players, but there are more players than this list that you can see here. So this is the solid tires and rubber, the component of Sri Lanka, where our people are contributing and massively progressing. So if you take textiles and solid tires and rubbers, so we consider all of these stuff as materials and composites. So when it's come to textiles, fiber selection to fiber development to starting from pellet to filament extrusion to there's a lot of stuff that material people can come and contribute. That particular part is coming from traditional textile industry, but when it's come to the novel textiles like smart polymers, advanced textiles and stuff like that, our people are the biggest problem solvers around that very spectrum, locating right sensors, devising of right actuators, understanding integration technologies and stuff like that are duties up to materials people. Same for solid tires and rubber, understanding the new compounds, the process optimization, testing, validation, quality assurance, and stuff like that are core duties that our people are profoundly contributing. The ceramics and building materials is again one of the prominent areas of Sri Lanka where our people are dominating. So these are some of the core players in the arena, the Lanka ties to Rossells to Mactize, Vitomix, Access. All of these areas, all of these companies that you can see here, our people are profoundly can be found. So this very industry is not only limited to the prior mentioned areas, but the breadth goes into some of the other areas as well. So these are some of the polymer-based industries where our people are heavily employed in, starting off with some of the profound and prominent cable manufacturers, switch and sockets manufacturers, So you will find a lot of materials people are performing pretty well in these sort of areas. So they are again working around compound development, compound formulation, quality assurance, design of non-destructive testings and stuff like that. I don't want to go into exact JDs or job descriptions here, but I'll try my level best to give you high level of explanation what these people are doing there. And I'm pretty confident that you must have heard of all of these companies. Uh, this is again a segment where our people are heavily employed in. And the metal processing is again one of the biggest contributors to the country's infrastructure development. So you name it, the Langva to Melva to Swiss Tech, Alumex, uh, the quality assurance to process optimization to heat treatment, alloy selection, alloy development, corrosion control. These are some of the core duties that our people would be contributing in these very areas in metal and metal processing and fabrication industries. Also, we have a great presence in glass and packaging materials. These are some of the key players in the industry. The Piramal to JFNI packaging, Korean Star packaging. Again, our people's core duty would be around understanding the quality management, material selection, material development, the due diligence of suppliers and things like that. This is again an area that you will find most of our people are profoundly working. So additional to that, you will find our people and the employment and the contributors are coming from the areas like paint and coatings, other construction materials, concrete admixtures, electronic assembly, and moving down into solar panels and the solar related developments as well. So I have compiled another list here, the emerging and niche sectors in Sri Lanka. So paint and coatings, Jet to Nippon to those part of the world, our people are there to understand the pigment dispersions, the material physics, dynamics, and things like that, quality assurance. Those are some of the very areas that our people are deployed in paint and coatings. The healthcare and medical devices is the same. The medical gloves, medical apparel, medical device manufacturing, sterilization. There are a lot of areas that our people can contribute in this very area. And these are some of the companies that I really would like to highlight, starting off with Jet to Nippon to Asian Paints, Aries Fentons, places like that. Then when it comes to renewable component, energy component, so I've seen a lot of our people are working at Aries Fentons on their solar platforms and things like that. Same for construction infrastructure. So these are some of the typical job roles that you may find it in Sri Lankan market. So a lot of our people are coming under quality control, quality assurance, and the places like head of research and development when it comes to some sort of senior roles. And also job roles like process engineer, head of production, head of engineering. So very recently, I had a conversation with one of my colleagues, and I found out that he's currently leading the group engineering function for AMW. So typically, somebody would think that person from a mechanical engineering background would lead such a function, but see the breadth of where our people can go into. Moving on, R&Ds again. I'm also coming from R&D segment. So head of R&D product and process development engineering, and those sort of areas are again that you would see a lot of our people can play a pivotal role. And it is moving from research director, R&D manager to chief operations officer to CEO level. So when it's come to the metallurgical, the metals space, again, I've seen typical job roles like metallurgical engineering, materials engineering in metallurgical, as well as go up into the levels like the head of manufacturing and things like that. And also some of the front-end operations like technical sales and application engineer. lot of my friends, my colleagues are working around this area as well, handling front end of the operations. Don't think that materials engineers are always at the lab spaces or the manufacturing landscapes, but they can easily go into the front end of the value chain and taking care of sales, the application consultancies and things like that. So that is why at the very beginning I said that material science and engineering is a very versatile field. Whatever the value chain that you can think of, whatever the place in that value chain, we are seeing a lot of our people are positioned in each and every part of that value chain. This is something I really would like to skim through. I'm pretty confident that Nayanthara must have touched upon some of these key areas. But in the global context, I've seen a lot of opportunities and our presence in aerospace and defense. Just to name a few, some of the particular areas like structural materials engineering, the coding and process engineering roles, non-destructive testing and developments in aerospace and defense. Again, energy and batteries, this is an emerging field of next generation batteries, the energy storages and things like that. Understanding what is the next level of electrodes would look like, energy storage devices, the battery cell developments, again, corrosion engineering, it's a massive field where the only discipline that can contribute to that very area is coming from material science and engineering. Biomedical and pharmaceutical is again pretty profound in material science and engineering. These areas are not only limited to the biologists and microbiologists and the chemists part of the world, but a lot of material scientists, materials people would come in handy to understand what sort of the polymers should come in handy, what sort of biomaterials should be developed. And when it's come to implants and such, like the pacemakers and stuff like that, for an example, what sort of materials to be picked, how the inertness should be maintained. So likewise, there are a lot of material related aspects would come in handy when it's come to biomedical and pharmaceuticals. Automotive is a self-explanatory area. All the materials development, lightweighting to the high strength materials to the so-called carbon fibers to graphene coatings, you name it, everything enabled through the wonders of material science and engineering. So I know personally a lot of our people, especially in jail, are the Jaguar Land Rover. Some of our people used to work there, understanding how their next generation material landscape would look like. The new developments around lightweighting, it's a big and a huge field of which is called the lightweighting, understanding the low weight structures and categories without compromising any of the traditional properties like the strength and the integrity and stuff like that. So that part of the world is dominated by material scientists and materials engineers. Also, they are known as composite engineers. So always understanding and locating new materials without compromising the traditional properties of current day materials. It is not only limited to that four. Our presence spans into semiconductors and electronics. I know a few people working for Intel, Foxconn and all, where they are working at their chip manufacturing divisions, chip design divisions, and places like that. Even construction and civil infrastructure is pretty profound in international landscape, especially in Middle East area. The minerals and mining processing is again an area that our people can contribute and complement. Don't think that this is an area only for mining people. When it's come to the real material characterizations, quality assurance, and things like that, the metallurgy, the mineral related, the crystal structures and things like that would come in handy for sure. So mineral and materials, the mineral processing is again an area that our people would extend their expertise into. So in global landscape, these are the four areas that I've seen when it's come to the job descriptions. So material characterization engineer is a very profound job role where you have to understand how to characterize an unknown material through different material characterization techniques. You will learn a lot during your coming sessions at material science and engineering department. Failure analysis engineer is again a very profound pivotal role in many industries, moving from aerospace to automotive to defense to you name it. There are a lot of opportunities are there for failure analysis engineer, the forensic engineering we used to call it as well. Whenever you see a failure, you have to understand the root cause. So when it's come to failures of mega structures to machineries to and things like that, so only our people, the material scientists and materials engineers, would come in handy to understand the root cause and identify the right level of remediation. Sustainability and circular economy is again a very profound and growing landscape, I would say. So there you have to understand how to develop sustainable materials without compromising any of the traditional properties. For an example, in textile industry, I personally handle few set of projects around here where like how well you can mimic the properties of synthetic fibers with natural materials. Synthetic materials are having its own attributes, own plus points. If you take for an example, a nylon. Nylon is a very powerful material, I would say. It's a synthetic material made out of petrochems. It's a very durable, very agile. You can do a lot of applications out of it. But at the end of the day, it's not degradable. So then we had to understand how to mimic nylon properties with natural materials. So it's not an easy task. That is where you have to deal with a lot of composite engineering just to understand through material fundamentals what is that nylon property and how the nylon atoms and the structure would derive it, and how well we can mimic it with some sort of like cellulosic materials, like natural materials. It's a proper materials engineering. So I just wanted to give you an example just to understand the breadth of it. So sustainability, circular economy is a massive field. A lot of opportunities will be derived out of that. Even in Sri Lanka, almost all the industries, all the exporters in Sri Lanka are very keen on this very area. So sustainable materials would be one of the key steps to enable the circular and sustainable ability related initiatives. Material qualification engineers, again, on material characterization, due diligence, and coming up with material testing methods, just to make sure that the material is ready for the intended application. So these are some of the key 4 areas that I could think of. There could be many, but I'm kind of confident that these are some of the key areas in international arena, how the materials people would come in handy under job categories. These job categories would span into a lot of different industries, semiconductors to construction to defense to pharmaceutical to whatever you can think of. These 4 would be profoundly established. Right. So that's the end of the technical, the part that I really wanted to touch upon. Then since it is all about the employment and the job opportunities and the industrial landscape of Sri Lanka and abroad, I thought of sharing some of the complementary areas that us as employers would look at when we are assessing an engineer or a material scientist. So these are some of the areas I really would like to give you an early indication. Just invest some quality time to look into these areas and understand how well these would complement to your very technical area. So these are some of the professional qualifications that I really would like to suggest you to at least look into and understand whether is it a good fit for you to complement yourself. So CIMA is again a very profound qualification in Sri Lanka where you would understand like some of the financial aspects, the project management related aspects of the businesses and things like that, where you would know how to assess a project, how to appraise a project. And I've seen, if you remember, some of the high level of the areas that I touched upon, moving away from material scientist core job role to more responsible positions like head of engineering, head of R&D, to factory manager, to research manager, to research director, and places like that. These things would come in handy. I've seen in places like plant managers, operation directors, and general managers, DGMs and all, they are pretty much equipped with these additional qualifications as well. So PMP is again something I really would like you to propose to have a quick look at it. Maybe it would be way too early for you to actively start some of these, but don't forget that these sort of complementary skills would always come in handy. So PMP is the global leader when it's come to project management. So if you are a PMP certified person, your employability would be skyrocketed, I would say, because the first and foremost thing is this qualification would make you industry agnostic. What I meant by that is maybe you would be a material scientist, but maybe let's say if you want to work in IT industry as an application engineer or someone, with PMP you can easily pivot into that very area, right? So that is the level of agility that the qualification like PMP would equip you. The CIM is all about marketing. If you remember, some of the front end roles that our people are playing, that sales and application engineering roles and things like that, if you people are equipped with SIM and things like that, your job role would be very easy for you to perform, and it will be an accelerator for you to climb the ladder. So I thought of adding this slide as well to give you some sort of a glimpse for you to understand there are other complementary skills as well that you might have to invest your time on to elevate your profile. Not only limited to that three, but there are some other areas as well. Like I don't want to go into a lot of details here, but Six Sigma, ISO standards, the SolidWorks, AutoCAD, some of the CAD and CAM related softwares. Having an understanding around these very areas would complement you at a very greater scale. Plus data analytics, programming, have an understanding on how to handle a complex statistical situations, data analytics, the big data analytics, having the understanding of how to mingle with these sort of tools and all would give you a better edge and make you give you a very high level of a competitive advantage, I would say. And when it's come to non-technical and soft skills, as a practice, I used to tell some of these areas as well, because this is, I would call it as an underdog, because I've seen a lot of technically competent people are failing due to the very fact that they are not equipped with these soft skills and professional competencies. So you have to understand, you have to know how to write a technical report and how to have a very crisp and precise level of communication. And you have to understand like how to do cross-functional collaboration, how to deal with people with different frequencies, different values, and coming from different disciplines and things like that. Because it doesn't matter how good you are in your own discipline, if you do not know how to collaborate, you won't be able to survive or succeed. And the English literacy is now an entry qualification. So, and us as employers, we are expecting you to be equipped with the minimum level of English proficiency, I would say, how to handle a conversation, how to present pretty well and things like that. But as a next step of it, now there is a tremendous trend on people understanding the ways of how to collaborate internationally, how to find international opportunities and things like that. So it would be good to understand the requirements like IELTS, TOEFL and things like that as well in your stage, that how to have a good band score, how to get better results for these particular qualifications as well, because either the marks that you have, the better the employability that you may find in international markets. And the final one is your personal branding and your presence in platforms like LinkedIn and such. Please invest some good quality time to compile a good profile, have a good profile picture, maintain a good portfolio, and get into a lot of areas and create, which would help you to create a good online presence and personal branding. There are a lot of opportunities out there in the university, outside the university. Now universities are pretty much linked to industry as well. So you will find ample amount of opportunities where you can collaborate with industries and like excel yourself and elevate your presence and work on your personal branding. So I thought of adding this to the today's conversation. And this is my very final slide. And I don't know how many of you would be ending up at material science and engineering, but I thought of sharing this very slide with you to give you a high level of spec sheet or a requirement set, uh, irrespective of the field that you are going to pick in, how to build your career as an engineer pretty well. So I'm using this very word called build your career intentionally. So that intentionality is something that I really wanted to emphasize here. So these are the four critical success factors behind how to build your career intentionally. The first factor is master your technical core. I also gave you a complementary set of areas like CIMA, SIM, PMP, and things like that. But I particularly said those are complementary skills. Your primary skill should be your technical core. So whatever the engineering field that you are going to pick in, you have to uh, be mastering at it. So invest some good quality time to understand the very fundamentals, principles, if it is material science and engineering, understand the very basics, fundamentals, first principles of material science, and be very confident at it, right? And then my second point is the very thing that I said secondarily, the things that would complement your career. You can assess whether you can pursue CIMA, PMP, Six Sigma, CIM. There are a lot of other complementary skills, including language skills as well, would complement and elevate your career. So that is very important for you to understand the balance between that two. Uh, Third one is how to build a global profile. Now, I'm confident that most of you are very interested in to understand and pursue careers in international landscape. If you are to go international, you have to be international. So then you have to understand how to build my career, how to have my international presence, how to be present in global forums. There are ample amount of global forums that you can participate free of charge just by investing your competencies. Just go into and understand the opportunities for that and build your global profile. And my fourth point is grow into leadership. So leadership is not simply a title. So wherever you go, try to acquire a certain level of leadership. For you to give the leadership, you have to acquire things like cross-functional skills, understanding, people management, strategic thinking, and stuff like that. All the other three would help you out to build your leadership traits as well. So be very mindful when it comes to leadership. Don't shy away when the leadership is given, because leadership is something would tremendously help you out to elevate and propel your career. So my final point is let yourself grow into leadership, right? So I really would like to conclude my this session with this very statement. The world's need materials engineers or engineers, right? Who can think beyond the lab, but into the boardroom. The very simple meaning of that is you have to create an impact. In corporate, we used to say always, what is your bottom line impact? All of your competencies, all of your skill sets and things like that should help the company out to uh, elevate its performance, elevate its competitive stance, and ultimately increasing its triple bottom line, right? The profitability, people, and the planet aspects, right? So your degree is just the foundation, right? And what you build on top of that is entirely up to you. So I believe that the very brief conversation that I had with you would help you out to understand at least what are the areas that I should be looking to, right? So please have the cross-referencing on the areas that I shared today. And I will also share my contact details with the forum organizers here. If you want to get more information around the very segment that I discussed about. And with that, I would like to conclude my session. And if there's any questions, I would really happy to answer if you have any questions out of this very session or any of the queries that you have on the industry as a whole. So thank you very much.
Thank you so much, Mr. Kalana, for that engaging presentation and for sharing all your know-how and experience on what it is like to enter the industry of materials science and engineering. And we will now move on to our second Q&A session. So once again, the QR code will be shared through the presentation, and you can access the Slido chat platform through the link provided in the chat as well. So please do send us your questions. Mr. Kalana, we have some questions from the Slido platform. Could you be kind enough to answer them for us? Thank you.
So the first question is CIMA qualification also an international recognition? The shortest answer is yes. It's offered by Chartered Institute of Management Accountants in UK. It's the globally recognized chartered arm for management accountants. So wherever you go, this will be heavily recognized. If you really consider the global landscape, especially in Europe and Australia, this would have an immense presence compared to United States. But even in US, this is pretty much accepted because this is the recognized global forum for management accountants. The second question is, where do we discover the global forums that you mentioned? There are global institutions. I'll give you a few examples. There is an institute called Institute of Minerals, Materials and Mining, IOM 3. For students, I believe that the registration is free of charge, but you can correct me if I'm wrong. And there are a lot of places like journals and things like that you should invest your time to understand, where you can publish your findings. When it comes to textiles and such, there are a lot of forums, like, for an example, World Textiles Innovation Network, WTIN, is again an open forum where they would heavily encourage global researchers to come and publish their work free of charge. And there is another forum called Innovation in Textiles. And there is another forum called Materials Research Society, MRS. There is another forum called American Chemical Society, ACS. And there are a lot of forums out there, folks. And they really do encourage global researchers to come and contribute. Sometimes for university students and such, the registration fees are waived off, totally free of charge. And even though they may charge some amount, it would be very minute. I believe that is within your acceptable range. So don't shy away from these forums. These forums are for the people like you. So once you have the presence in these forums, people would get to know about you, would get to know about our university, about our country, the work that you would do. Those are some of the areas. And also LinkedIn is a very good platform for you to share some of your findings, even to the date. If I am to find some of the solutions for some of our problems, I really do go into LinkedIn and identify the people in that very area. So please do use some of these platforms and actively use it. When you first started applying for jobs, what did you take into the consideration? That's a very good question. So in most of the cases, people are considering their first salary into the consideration. So I did the same. I actually had a balanced scorecard. I had a particular set of requirements. So salary and remuneration was one of my selection criteria. But also on top of that, I had a few areas like my room for growth and the presence of that very organization, whether it's a locally bound organization or an internationally bound organization. So I was looking into that as well. Then I did my due diligence and my background study on like what sort of growth opportunities that some of our past graduates were given. So I would say, in a nutshell, your personal remuneration and package was one of my considerations, and your room for growth, and the level of exposure that you are getting, and the level of network that you can build with your employment were some of the key engagements or some of the key consideration that I had when I was assessing between the employers. Do you know any professionals who earn their MScs, PhDs abroad in material science? Yeah, a lot. There's a substantial category, and the number of people who go for abroad to take care of their MScs and PhDs and do come back. Some of them are directly going into academia, and there is a sizable quantity would come into the industry because the industry is heavily accepting and welcoming people like them because they are bringing in a lot of competency, lot of network, lot of ecosystem. So whenever we come across with a problem, they know where to go and to whom to connect with. So that competency is heavily valued. So the simple answer is yes, there are a number of people who are currently working in the industry with MScs and PhDs getting from abroad. What are the government job opportunities for MSc engineers in Sri Lanka? There's a lot. Uh, some of my colleagues are working at this entity called NBRO. I can't remember the long name of that. It's where like whenever you do a development or building up some establishment, things like that, there is a research has to go down into that building, the soils and things like that. It's a government entity called NBRO. And there's another government entity called Central Engineering Consultancy Bureau. It's where like it's the government entity for civil engineering consultancy. So when it comes to civil engineering, the civil engineering material-centric activities are done by materials engineers, not by civil people. So whenever you see a development, whenever you see a civil engineering entity, there is a particular establishment called construction materials, and that responsibility will be always given to a materials engineer. So wherever you may find a consultancy, the civil related activities, civil engineering, government related civil engineers, there will always be an entity for materials engineers. So NBRO is there, Civil Engineering Consultancy Bureau is there. And if you really go into research and stuff, the SwinTech is a prime example. ITI is again a prime example for characterization and testing services. A lot of our people are working there. You can get the contacts from our department, and you can get into more details through them. Yes, the simple answer is yes. A lot of opportunities are out there. Yeah, this one I answered, I guess. Do materials engineers have jobs that much in Sri Lankan industry with a good salary too? Yes, it's a definite yes. That's the very reason I really wanted to show you all of these companies. I added 53 companies very quickly. There are 100 plus companies in Sri Lanka. So for a batch, we are only recruiting 47 to 50 people. Even if one go to one industry, there are ample amount of companies out there for you to get employed in. So employability, without a doubt, is 100% there. And the good salary is a good question. It's a very classical question. You can't compare your initial salary with the fields like IT, right? Because IT people are known to be giving a substantial initial salary. But I can assure you this, I don't want to go into exact numbers, but with the experience and all, with the responsibilities that you're holding up, after 5 to 6 to 7, maybe after 10 years of time, the level of exposure, the level of responsibilities, definitely the package that you are getting as a material scientist or an engineer with a management background would be substantially higher. Because I have some of my very closest friends, I have had some very intricate conversations with them. Then I found out the differences are not that much after 5+ years. Then whenever you surpass 10 to 15 years, it goes other way around. especially people like mechanical engineering, materials engineering, civil engineering, where the manufacturing experience and the ecosystem is related, are getting remunerated pretty high because the responsibility that they're holding is immense. The number of people that they're responsible are huge. Because of that very nature, these people are required to be remunerated pretty well. That's the very reason. So the salary equation is I can guarantee you that it's not a problem. So at the very beginning, I think even right now you can land on a six-figure salary around 100,000, 150,000. I recently got to know that one of our students got recruited to one of our companies around 175 or 65,000. That itself is a good starting salary, I would say. So right now I'm seeing even the starting salaries are around 150,000 to 175,000, which is not a bad deal at all. And the other biggest thing is your development trajectory is pretty evident. You can earn a lot. Your first increment would be substantial. Then you can go for promotions. In manufacturing, there are a lot of layers out there. Then you can climb the ladder easily. Whenever you climb the ladder, your salary would be adjusted accordingly. Yes. First and foremost thing is be very confident in fundamentals of materials, because biomaterials and nanomaterials are not what you call a very separate stuff. Those are part of the materials family. So be very confident in materials fundamentals, how material thermodynamics would work, how atomic level the mechanisms would work, and things like that. Be very confident with materials fundamentals, and then whenever you are moving away from biomaterials to nanomaterials, you would know how to apply these principles. For an example, I did the same. I am in the core development areas of textiles. I did not learn anything around textiles in my tenure at Material Science and Engineering Department, but I knew the fundamentals of materials. So whenever I'm given a new material, I know how to mingle with it, how to engineer it, how to adjust or alter its properties, and how to play with it, and things like that. Similarly, for biomaterials, for nanomaterials, be very confident and competent in the material fundamentals. Then you would know how to go into some of the intricate and the specific areas like biomaterials and nanomaterials. So when it's come to nanomaterials and biomaterials, I believe there are particular modules allocated for these very areas. So in the program, you will be properly equipped with the fundamentals and the required know-how around these areas. And yeah, during your curriculum, these areas will be critically covered. So yeah, I don't see a problem with that. What was your final year semester GPA after completing all 8 semesters? I had around 3.5. The beauty is I started with 2.33. Then I had to work a lot to build up my GPA, overall GPA. But I started off with 2.33, but at the end of semester 8, I had 3.5. So it's a pretty achievable target. Can you scroll a bit down? I can't see the entire question. I can't read the question for some reason. Can someone read the question for me?
Yes, of course. I noticed many Sri Lankan scientists in academia and industry focus more on experimental work than first principles thinking. Is my observation correct, sir?
It's partially correct. Because in industry, we are always struggling with timeline pressures. So sometimes we may not be given the luxury of always going into first principles and fundamentals for us to unlock some of the problems. That is why we are effectively connecting with academia, and we expecting academia to be very profound in first principles and walk us through along that for us to jointly solve the problem. So your observation is not entirely correct, but it's not entirely incorrect as well. But always keep that as a practice. Always go down into first principles and fundamentals. It is where you would not require to do many repetitions and iterations. Straight away, you can derive your answer whenever you move forward with first principles. between the industrial sector and research, which is more prominent, offers more opportunities in Sri Lanka. Research is, if you consider any part of the world, is a very niche area, I would say. So research is somewhat restricted. And when it's come to R&D, they are very keen on, even us when we are evaluating people, we are very keen on the academic performance as well to a certain extent. And because it's sort of an indicator that the level of impact that they can impart to the equation. And when it's come to the industrial research, even in Sri Lanka, industrial research is pretty profound. I know for a fact, MS Innovation Private Limited it's a company which has established purely to take care of R&D work. It's the only company in Sri Lanka. Then John Keel's has started it for JKX for John Keel's research. Now LOLC is heavily interested in investing in new materials technologies. They recently started advanced graphene technologies or something where they critically work on graphene related developments, and I have some engagements with them as well. So industrial research is pretty profound, and if you really move away from the industrial research to industrial manufacturing, that is pretty established. All the manufacturing related areas and all materials engineers are heavily required, from metal to ceramic to polymer to composites to construction to you name it. A lot of industrial opportunities are pretty much out there. Are there any additional certifications? I think I touched upon this. There are additional technical capabilities and competencies that you can think of, as well as there are non-technical capabilities and competencies that you should think of. I would like to recommend you to invest some good quality time to be equipped with both of these areas on top of your materials engineering degree. That will always come in handy. It would be CIMA, it could be PMP, or it could be Six Sigma, because these are globally accepted qualifications. Wherever you go, they would know. If you are equipped with black belt Six Sigma, anyone would know what is meant by black belt in Six Sigma, right? Anyone would know PMP, anyone would know CIMA. Yeah, so there's a segue for the next question. CGMA and CIMA are the same. CIMA is the institute's name, Chartered Institute of Management Accountants, and the CGMA is one of the qualifications offered by them. So if you are a member of CIMA, you usually call them as would start with associate membership, ACMA. Once you're equipped with ACMA, you can ask go for CGMA. It's a matter of submitting some documentation and things like that. It's again an additional qualification as a part of CIMA. So again, CIMA is the institute's name, CGMA is a qualifications name. The delta, the difference. I think the biggest difference is the critical thinking. Because in university, we can't blame for that, because in university is trying their level best to equip you with the right level of skill sets and competencies in that particular area. If you are to complete in material science and engineering, you should know the very fundamentals and the basics of material science and engineering. So it's university's duty to give you the right level of information, academic info, the lessons and things like that. But on top of that, you have to understand how these principles would be applied. And whenever you are given a problem, how to recall the things that you learned at the university, how that can be recalled, just to make sure that you are adhering to the first principles and fundamentals whenever you are deriving a solution. That is where an engineer and a mere technician would differ. Otherwise, anyone can come up with a crazy new idea without knowing fundamentals. There's a 50-50 chance it may work, it may not work. But whenever you're equipped with right info, right first principles and fundamentals, you know how to think, what sort of trajectory to be followed, and things like that. So two different duties I can see. In the university, their prime duty is to equip you with the lessons and the fundamentals and things like that. But you as an individual, you have to understand it is not enough. You have to understand, like I said, the complementary skills and competencies that you have to grab, as well as how to use all of these to create the impact to the industry. You will be given a lot of industrial problems, develop new materials and things like that. In that quest, you have to recall all of these. The biggest gap I'm seeing is the transformation time that a student would take is pretty substantial. Whenever you step into the industry, you have to switch very quickly, right? Because you are not expected to sit for exams, vivas, and things like that. That era is over. Now it's a matter of you applying those and think critically, very quickly, timely nature, showcasing your capabilities and competencies, right? Setting the right examples. So that is some of the biggest the gaps that I'm seeing between the university and the industry. Are there opportunities in Sri Lanka for researchers working in across scientific computing, instrumentation, and material physics? These are very intricate areas, I would say. In Sri Lanka, these sort of areas, the openness and the availabilities are somewhat restricted and somewhat marginal, I would say. But if someone is really interested into these areas, the best bet would be understanding and pursuing in higher education in abroad, identifying the better universities who got their specialty in these very areas and go into those areas and build your career on top of that. Because in Sri Lanka, unfortunately, at the moment, heavy researchers are not focusing on material physics, the computing and things like that for drug discoveries and stuff like that. We don't have the bandwidth or the instrumentation nor the infrastructure. But there are, in a very in a clustered manner, then and there are some developments happening in universities. But I can confidently say in industry, it's not very prominent at the moment. Can you go a bit down so I can read the question, please?
Shall I read it out for you, Mr.
Yes,
Khan?
please. Please,
Yes.
yes.
Okay. Do most industrial research follow first principles modeling and simulations, experiments and prototyping, or is first step often skipped? What flow do you follow?
No, we don't have the luxury of skipping that first stop, because in industry, remember this statement, we have to fail fast, fail cheap. For us to fail fast and fail cheap, we are not expected to start it off with prototyping rapidly. We have to do everything on paper. Not literally on paper though, but we are doing a lot of simulations in softwares and things like that. See how the solution would behave in real environment, and once we are confident with the simulation phase, straight away we would move into the materialization or the prototyping part. So the skipping of first step is not something I would recommend, and not happening in the industry in a higher level of frequency as a practice. But then and there are sometimes there would be some exceptions. Don't be very extreme about the situations. Sometimes you have to do quick experimentation and see in real world how it would behave. But in most of the cases, always remember that statement: fail fast, fail cheap. The best way to get that tested is through simulation. So we are heavily investing on simulation related tools and things like that to get that part done. Anything else to be added? Happy to answer any more questions that you are having, if you are having it.
I think we went through all the questions that we got. So thank you so much, Mr. Kalana, for sharing really detailed answers about your experiences and for like thoroughly answering all the questions that the students had about what it is like to be in the industry related to material science and engineering. And I think we all learned a lot from your session as well. So as we come to the end of today's session, I would like to extend our sincere gratitude to our speakers, Dr. Nainathara Hendenia and Mr. Kalana Bamanuarachi, for generously sharing their knowledge, experiences, and valuable insights with us. Dr. Nainathara, thank you for inspiring us through your journey in research and for giving us a glimpse into the exciting opportunities available in academia. And Mr. Kalana, thank you for sharing your experiences from the industry and demonstrating how materials engineering drives innovation and contributes to the development of products that make a meaningful impact. I would also like to thank all of you for joining us this evening and for your active participation and enthusiasm throughout the session. Finally, on behalf of the Department of Material Science and Engineering, University of Moratuwa, I would like to thank everyone who contributed to organizing this event and making it a success. We hope today's session has given you a better understanding of materials engineering and inspired you to explore the many opportunities the field has to offer. Thank you once again for joining us, and we hope to see most of you in our department in the upcoming semester. So have a pleasant evening and goodbye.
Thank you very much. I wish you all the very best.
Thank you for
Thank
having
you.
me and wish you all the best, all of you.
Thank you so much. Thank you, Dr.
Thank you, sir and
Nanaka
madam,
and Mr.
both of you.
Chalana.